Differentiate with respect to x the function x cos x to the whole power x plus x sin x to the whole power 1 by x. Let this be equals to fx. Hence, take the first term x cos x to the power x equals to t. Take natural logarithm on both the sides. We get log t equals to x log x cos x, which can be written x into log x plus log cos x. Applying the property log ab equals to log a plus log b. Now differentiate with respect to x on both the sides. We get 1 by t dt by dx equals to, use product rule to evaluate the RHS. We get log x plus log cos x plus x into 1 by x plus 1 by cos x into minus sin x. Cross multiplying t on the other side, we get dt by dx equals to x cos x to whole power x into log x plus log cos x plus 1 minus x tan x. Similarly, take the second term x sin x to whole power 1 by x equals to k. Natural logarithm on both the sides, we get log k equals to 1 by x into log x plus log sin x. Differentiating both the sides with respect to x, we get 1 by k dk by dx equals to, use product rule on the RHS. We get log x plus log sin x constant, d by dx of 1 by x is minus 1 by x square plus 1 by x constant, and d by dx of log x plus log sin x is 1 by x plus 1 by sin x cos x. Hence, cross multiplying k on the other side, we get dk by dx equals to k by x square into minus log x minus log sin x plus, this is simply 1, and this is x cot x, 1 and x cot x. Hence, dk by dx equals to x to the power x sin x to whole power 1 by x into x cot x plus 1 minus log x sin x whole upon x square. Here we have used the property log a plus b equals to log ab. Now we know y equals to t plus k. Hence, differentiating this with respect to x on both the sides, we get dy by dx equals to dt by dx plus dk by dx. Replacing the values of dt by dx and dk by dx in this equation, we get dy by dx equals to this. Thank you.